Hello and welcome everybody to Paper Talks. Today we're doing a deep dive into a brand new, pretty comprehensive report. It offers a critical look at the science of climate change and its impacts specifically on the U.S. climate. This deep dive is based on a significant document, a critical review of impacts of greenhouse gas emissions on the U.S. climate, just published by the U.S. Department of Energy on July 23, 2025. It's a substantial piece of work, and, well, it sets out to do something quite specific.
Right. What's fascinating here really is that this report was specifically commissioned to, and I'm quoting here, encourage a more thoughtful and science-based conversation, and also to highlight evidence and perspectives that challenge the mainstream consensus on climate change. It's deliberately framed as an independent review by a group of distinguished scientists.
Okay, let's unpack this. So what's the sort of big takeaway message from this report, and what lasting impact is it trying to have on the conversation?
Well, the overarching message is that while climate change is real, its impacts, particularly here in the U.S., are often, they argue, significantly exaggerated. It even identifies several beneficial aspects of rising CO2 levels.
Beneficial aspects, okay.
Yeah. Its main intent seems to be reframing the discussion, arguing that climate change is, quote, a challenge, not a catastrophe, and that policies based purely on fear could actually be more detrimental than climate change itself. It really pushes for a much more nuanced, evidence-based approach to policymaking.
That's a truly provocative starting point, isn't it? Our mission today, then, is to impartially explore these arguments. We'll walk through the report's key findings pretty much chapter by chapter. You'll hear about areas where this report highlights data, interpretations that differ sometimes quite significantly from what's often presented. We often hear about the negative impacts of rising CO2, right? But what if some of those narratives are maybe incomplete? Our deep dive into this Department of Energy report starts with something potentially surprising: the direct and sometimes, as you said, beneficial effects of CO2 on the environment.
Yes. One of the report's most striking findings, I'd say, is CO2's contribution to what they term global greening. Satellite data from multiple studies, actually, consistently shows a significant increase in Earth's vegetation over recent decades. And a large percentage of this greening is directly attributed to rising CO2 levels.
So it's literally helping plants grow more.
That's the claim. It suggests CO2 is helping plants thrive across vast regions, apparently even in arid areas, by improving their water use efficiency.
So CO2 is essentially acting like a plant fertilizer. That feels like quite a departure from, the usual conversation.
It is, in some ways. The report reminds us that CO2 is absolutely essential for photosynthesis. I mean, that's basic biology, right? Plants evolved under much, much higher CO2 levels in geological history, way higher than our current, say, 430 parts per million. Even today's levels, the report argues, are below optimal for many common plant types, the C3 and C4 plants, which are crucial for ecosystems and agriculture.
Right.
And elevated CO2 also helps plants retain water longer. It lets their stomata close more, improving water use efficiency, basically more biomass for the same amount of water.
And the report points out that these CO2 fertilization benefits aren't always front and center in the big climate reports.
That's right. It notes that while these benefits are acknowledged in some detailed working group chapters of, say, the IPCC assessment reports, they're often downplayed or sometimes completely absent from the high-level policymaker summaries and synthesis reports. And those are the parts most people actually read.
Okay, right. Now, here's where it gets really interesting. What about ocean acidification? We hear that term constantly. The report seems to challenge that narrative quite directly.
It does. The report calls it the alkaline oceans, arguing that ocean acidification is actually a misnomer.
A misnomer. How so?
Because oceans aren't expected to become acidic, pH below 7, they're becoming less alkaline. So ocean neutralization would be a more accurate term, according to the review. While CO2 absorption does decrease pH, the report notes this change is within the range of natural variability over long geological timescales. Ocean life has evolved in periods when oceans were even mildly acidic.
Okay. And what about the impact on coral reefs, specifically the Great Barrier Reef? That's often held up as a prime example.
Yes, the report looks at concerns about reduced coral calcification rates. It highlights an earlier, quite alarming study that linked Great Barrier Reef decline to decreasing pH. But that study was later corrected, showing no significant change in calcification.
Ah, correction.
Yes, but what's striking, the report points out, is that the original, more alarming paper continues to be cited far more frequently than the correction.
That's interesting in itself.
It is, and moreover, the report highlights that the Great Barrier Reef has actually shown considerable growth in recent years, with hard coral cover reaching record highs in some regions, and this is despite rising CO2 levels.
So it's potentially a case where the initial, more dramatic findings get more attention than follow-up corrections or, contradictory data.
That's precisely the report's contention. It explicitly cites publication bias, suggesting that alarming ocean acidification results might be preferred by high-impact journals, potentially leading to an exaggeration of negative impacts. One meta-analysis even found what they called an extreme decline effect in some studies on reef fish behavior. Initial dramatic results followed by later studies showing much smaller or even no effect. It's a crucial point about critically evaluating scientific literature.
Okay, given these, surprising insights into CO2's direct effects, the report then shifts. It looks deeper into how we even measure human influences on climate, and it challenges some fundamental tools. What does this mean for things like radiative forcing and emission scenarios?
Right, so the report starts by putting climate change in context. It's a natural phenomenon throughout Earth's history, influenced by internal fluctuations, think ocean circulations, and external forces like the sun and volcanoes, in addition to human activities. CO2 is identified as the largest human influence, sure, but the report stresses that aerosols, those tiny particles in the atmosphere, exert an overall cooling effect, but with large uncertainties.
Okay.
It also highlights that the IPCC generally assesses solar radiative forcing the sun's warming effect as negligible. But this view is disputed by some studies mentioned in the report. These studies suggest solar activity's contribution to late 20th century warming might be underestimated, perhaps due to data gaps or even suppression of dissenting views.
Interesting. And what about the CO2 levels themselves and the projections for the future? We're around 430 ppm now.
Correct. The report reiterates that CO2 levels were much lower, like a 180 ppm, during past ice ages. And those C3, C4 plants we need would be in trouble at even lower levels. Now, this section is particularly critical of the IPCC's emission scenarios, the projections of future greenhouse gas levels.
So?
The report states that IPCC projections have, and I quote, tended to overstate actual subsequent emissions. For example, RCP 8.5, often called business as usual, was actually presented here as an extreme worst-case scenario.
Right, I've heard that criticism before.
And the report argues its widespread use created a bias towards alarm in the climate impacts literature. It points out that observed global CO2 emissions have actually tracked well below most of these higher-end scenarios.
That's a pretty strong claim about how our future climate outlooks are being shaped. And what about the effect of cities on temperature readings? Urban heat islands?
Yes, the UHI effect. The report suggests historical temperature data, collected mainly where people live, might be biased upward by cities retaining more heat. It questions whether the data cleaning procedures fully remove this bias, citing studies arguing UHI could contribute significantly, maybe 30–50%, to observed warming in certain areas. They argue the IPCC's assessment of less than 10% bias is, unsubstantiated.
Okay, this leads us straight into climate models, doesn't it? They're so central to projections. The report seems to dedicate a lot of space to their limitations.
It absolutely does. The report is quite explicit, saying climate models are not fit for the purpose of determining the equilibrium climate sensitivity, ECS, and it highlights discrepancies between models and instrumental observations.
And ECS, just to remind everyone, is how much warming we expect if CO2 doubles.
Exactly. It's a crucial measure. The report notes that while earlier estimates had a wider range, recent evidence, often from data-driven estimates rather than models, suggests a lower and narrower range for the median ECS.
And it seems the models themselves have some built-in issues or warming biases.
That's a key criticism raised. The report criticizes using these big general circulation models, or GCMs, for ECS. It notes concerns about tuning them to match past records, especially how they handle clouds. That's a huge source of uncertainty. In fact, the spread of ECS values in the latest models, CMIP6, is actually larger than in the previous generation, CMIP5, which suggests the problem hasn't exactly been solved.
Not getting narrower.
No. And the report details several warming biases, where models seem to run hotter than observations. For instance, medium and high ECS models apparently conspicuously overpredict the warming since about 1980.
So the models are running hot compared to what we're actually measuring, particularly in key areas.
Precisely. Models, on average, seem to overstate warming in the tropical troposphere. That's a critical region for detecting the greenhouse warming signal. This bias is apparently global now and has worsened over time. Observed trends are often below the entire range predicted by the models. Furthermore, while models predict the stratosphere should be cooling, Warming has actually been observed there since 2000, contrary to projections. That challenges the supposed fingerprint of human-caused climate change. The report also mentions mismatches in snow cover models predict declines in Northern Hemisphere winter snow, but observations show it's constant or even increasing. And a big discrepancy in the U.S. Corn Belt, where models predict much faster warming than observed. The conclusion drawn is that models are not fit for purpose for reliable regional climate outputs.
Okay, having gone through the broader climate trends and the challenges in modeling them, let's drill down into something we all experience more directly.
Extreme weather.
Does the report's perspective on things like hurricanes, heat waves, droughts align with the common narrative?
Well, the report's consistent message here is that, quote, most types of extreme weather exhibit no statistically significant long-term trends over the available historical record. It cautions heavily against linking single events directly to human influence. It stresses how short our reliable observational records are, maybe 130 years, compared to natural climate swings over centuries or millennia.
Right. So what about hurricanes specifically?
It points to the latest IPCC assessment, AR6, which states low confidence in most reported long-term trends in hurricane frequency or intensity. Global hurricane frequency actually shows a weak decrease. U.S. landfalling hurricanes show no statistically significant trends since 1920, and only one of the 10 strongest U.S. landfalling hurricanes happened this century.
Okay. What about heat waves? They certainly feel more common, don't they?
The report contends that U.S. heat waves are, quote, no more common today than they were a century ago. It criticizes metrics that use starting dates, say in the 1960s, which might inherently show an increase, and it again points to the significant influence of urbanization, the UHI effect, on rising nighttime temperatures in cities. It concludes that greenhouse gas emissions have had little to no effect on heat waves once you account for urbanization and natural variability.
And for other events, like extreme rain, tornadoes, floods, droughts, what's the verdict there?
It's a similar pattern. While some reports find increases in heavy precipitation, this review cites studies finding no significant trends in various U.S. regions if you use longer time series. For strong to violent tornadoes, EF3, EF5, in the U.S., there's actually been a substantial decrease by about 50% since 1950.
A decrease?
According to the data cited, yes. For flooding, the report notes low confidence for observed changes globally, and no robust evidence that these trends are attributable to human influences in the U.S. As for droughts, U.S. long-term data shows an insignificantly declining trend in extreme dryness. And on wildfires, global activity shows a downward trend this century, with U.S. data strongly emphasizing the dominant role of forest management practices, not just climate change.
Okay, let's move on to sea level. We constantly hear about rapidly rising oceans. What does this report offer on that?
It acknowledges global sea level rise, of course about 8 inches since 1900, but it really stresses the significant regional variability and the importance of local factors that go beyond just climate change.
Like the land itself moving.
Exactly. Along U.S. coasts, local land motion subsidence, sinking, or uplift is often a dominant factor, sometimes comparable to or even exceeding the climate signal. It gives examples like San Francisco, mostly due to soil compaction apparently, and New Orleans, largely due to geological subsidence and less sediment from the Mississippi River.
And those projections for places like New York City, predicting a foot rise by 2050.
Yeah, the report notes NOAA's projection for NYC as remarkable. That's more than double the current rate. And it notes NOAA says it's locked in regardless of future emissions. The report kind of wryly suggests we'll know in a decade if that prediction holds water, so to speak. Overall, the latest IPCC projections for global sea level by 2100 still show, quote, deep uncertainty, mainly because of how unpredictable ice sheets are, especially under higher emissions scenarios.
Okay, and then the really big question.
Yeah.
Attribution, figuring out what caused what. The report seems to suggest this is way more complex than often portrayed.
Absolutely. Attribution, identifying causes. The report highlights significant uncertainties and challenges in attributing climate changes, especially extreme events, directly to human CO2 emissions. It makes a distinction between detecting a change, seeing something statistically significant, and attributing its cause. Attribution requires understanding all the causal factors and ruling out alternatives, which it calls exceptionally challenging due to complexity and data limits.
And it pushes back on the IPCC's view on natural variability too, right?
Yes, it does. It challenges the IPCC's assessment that natural variability has had a minimal impact on recent warming. It points to evidence suggesting larger impacts from solar variability, including solar indirect effects that aren't fully baked into climate models. And it emphasizes large-scale ocean cycles, like the AMO and PDO. These have significant multi-decadal impacts on global temperatures. The report argues that climate models tend to average these oscillations out, effectively canceling the role of natural internal variability in the attribution process.
And for attributing specific extreme events, like that big heat wave out west a few years back, the report is pretty critical of the methods used.
It is very critical. The report takes aim at the field of extreme event attribution, or EEA, and specifically organizations like World Weather Attribution. It highlights criticisms of their approach, things like a lack of a formal detection process, an implicit assumption that basically 100% of post-industrial warming is human-caused, and failing to properly account for internal climate variability. The report uses the 2021 Western North America heat wave as a key case study. While some groups attributed it strongly to human-caused climate change, this report cites several counterarguments suggesting the event was, quote, virtually impossible under any previously experienced meteorological conditions, with or without global warming, or just bad luck, or caused by rare meteorological conditions that were not made more probable by global warming, even if overall warming added a tiny bit to its magnitude.
So a lot of scientific debate still happening there.
Definitely. The estimates of its rarity or probability are deemed not accurate because it was such an extreme outlier statistically.
Okay, so if the impacts and the attribution are presented as this uncertain, what about the actual real-world effects on things like agriculture, human well-being?
Right, the report offers a distinctly different perspective here, too. It argues the overall picture is more nuanced, often more beneficial, or at least less damaging than widely believed, particularly for the U.S. agriculture. The report asserts that rising CO2 levels benefit plants, including agricultural crops, and that the associated warming will be a net benefit to U.S. agriculture.
A net benefit? How?
Well, studies cited show significant yield increases in various crops with rising CO2. And as we mentioned, CO2 also enhances drought tolerance.
And it seems some previous economic models used for policy might have missed these agricultural benefits.
That's what the report argues, yes. It highlights a key study previously used by the EPA to justify higher estimates for the social cost of carbon, or SEC. This study apparently had incomplete agricultural data. When the missing data was recovered, the report claims the projected crop yield losses, quote, disappeared and turned into gains at all warming levels.
Wow, that's a significant revision.
It is. It also notes that while some studies show nutrient levels might decrease slightly as biomass increases with CO2, the evidence is mixed, and adaptation strategies like adding nutrients are effective.
Okay, what about managing the risks of extreme weather in society? You mentioned earlier trends aren't always clear, but how are we coping? Has our resilience improved?
The report makes a strong case that the evolution of climate risk in the U.S. is actually dominated by societal factors, rather than by changes to the actual weather and climate hazards.
Meaning?
Meaning deaths from weather disasters have decreased substantially since 1900, even with huge population growth. This is attributed to increasing resilience and adaptation, things like better infrastructure, warning systems, improved forecasts.
I see. It also notes that NOAA's billion-dollar disaster list, often used to show rising costs, was withdrawn recently because it failed to properly adjust for increases in population and wealth in vulnerable areas.
Ah, so more stuff in harm's way could explain rising costs, not necessarily worse weather.
That's the argument presented. The apparent increase in costs is largely due to more people and more valuable property being exposed, not necessarily more frequent or intense events per se.
That makes sense. What about deaths from heat versus cold?
This is a really interesting point in the report. Globally, it states, mortality is substantially greater for cold conditions than for hot conditions. Studies cited found cold weather kills many times more people than hot weather. One found 18.5 times globally, another 14 times for the U.S.
14 times more deaths from cold than heat in the U.S. That's what the cited studies found. And in the U.S., there's been a huge decline, 3/4 to 90% in heat-related mortality since the 1960s. This is attributed to adaptation, especially air conditioning and better health care. So the report concludes, rising temperatures are often associated with a net saving of lives because the reduction in cold deaths outweighs any increase in heat deaths.
A net saving of lives. That's counterintuitive.
It certainly challenges the common narrative. It also highlights a crucial point. Even with heating and cooling available, the inability to afford energy leaves low-income households exposed to weather extremes. Energy costs matter.
Right. And finally, let's turn to the economy. What does this report say about the overall economic impacts of climate change and that metric, the social cost of carbon?
The report echoes a view that's been around for a while, actually, that climate is a relatively unimportant factor in economic growth. It cites economists like Schelling and even the IPCC's fifth assessment report, AR5, which stated climate change impacts are small relative to the impacts of other drivers like population, technology, and governance.
So other things matter much more for economic growth.
That's the perspective. Empirical studies, including some looking at U.S. state-level data, apparently suggest cold weather shocks actually have larger negative economic effects than warm ones. This implies warming could even yield a net economic benefit for the U.S. The report also points out that while the globe warmed about 1.3 degrees C since 1900, humanity prospered massively longer lifespans, huge economic growth, dramatically fewer deaths from extreme weather.
So the historical correlation isn't necessarily negative.
Not according to this review. It critiques an influential 2012 study that found warming harms growth in poor countries, calling it not robust. It says later studies find no detectable negative temperature effect on global GDP growth or even find net positive effects in many countries, especially developing ones. Even the Biden administration's own analysis is cited, showing that a few degrees of warming would likely have only a few % impact on U.S. GDP, which the report calls negligible compared to typical annual growth rates.
Okay. And the social cost of carbon itself, that dollar estimate of damage from emitting one more ton of CO2.
The SCC is presented here as highly uncertain and not intrinsically informative. It's described as basically an if-then statement, heavily dependent on the assumptions you feed into the models.
What kind of assumptions?
Things like discount rates, how much you value future costs today, climate sensitivity, ECS, which we discussed, and the damage functions, how exactly temperature changes are assumed to affect economic conditions. Changing these assumptions dramatically alters the SCC value. The report argues that the EPA's big five-fold increase in its preferred SCC value in 2023 wasn't driven by new data, but by new assumptions, including those arguably flawed agricultural damage estimates based on the study with missing data.
I see. And what about tipping points? Those abrupt, large-scale changes.
The report acknowledges them, but argues that even considering them leads to only a modest increase in the SCC value. It also notes the IPCC assigns low probabilities to most potential tipping points. And it adds, if such events are truly unpredictable, maybe policy should focus more on building resilience to any kind of major disruption, not just climate-related ones.
Okay, resilience again. Finally, let's talk policy directly. What does the report say about the actual effectiveness of U.S. emissions policies on the global climate?
It delivers a very, very blunt assessment on this. Quote, U.S. policy actions are expected to have undetectably small direct impacts on the global climate, and any effects will emerge only with long delays.
Undetectably small. Why?
It comes down to scale and physics. Unlike local air pollutants like smog, CO2 hangs around in the atmosphere for decades, even centuries, and mixes globally. The report emphasizes that U.S. emissions are just a fraction of the global total. For example, all U.S. cars and light trucks combined account for only about 3% of global energy-related CO2 emissions.
Only 3%. So even if the U.S. eliminated all vehicle emissions tomorrow, the global impact would be tiny.
That's the argument put forward. Eliminating all U.S. vehicle emissions would apparently retard the accumulation of CO2 in the atmosphere by maybe a year or two over a whole century. It would reduce the overall global warming trend by at most about 3%, which the report says is far below the limits of measurability, given the noise in the climate system and the precision of our measurements.
That's quite a statement about policy effectiveness.
It is. The report strongly advocates for a more nuanced and evidence-based approach for informing climate policy that explicitly acknowledges uncertainties. It calls for using realistic assumptions about future emissions, reevaluating climate models to address their biases and uncertainties, and clearly acknowledging the limitations of extreme event attribution studies. The overall recommendation seems to be an approach that acknowledges both the potential risks and benefits of CO2, rather than relying on flawed models and extreme scenarios.
So wrapping this up, what we've just unpacked is a truly comprehensive, Critical review from the U.S. Department of Energy. It really does challenge many common assumptions in the climate conversation. It highlights potentially overlooked benefits of CO2, points out significant discrepancies between climate models and real-world observations, and urges a much more cautious, data-driven approach to understanding impacts and the effectiveness of policy.
Yeah, connecting this to the bigger picture, the report fundamentally suggests the narrative around climate change needs more open debate. It calls for a deeper look at all the data, including data that might contradict the prevailing consensus. It really emphasizes that our ability to measure and attribute changes, especially at regional scales or for specific extreme events, is still filled with uncertainty and potential biases.
Which raises a really important question for you, our listener. In a world absolutely saturated with information, how do you critically evaluate scientific reports like this one, especially when they present perspectives that challenge what you typically hear? And maybe think about what this report implies. Should the focus shift more towards resilience and adaptation to environmental changes, rather than perhaps solely on prevention strategies, particularly if the measurable impact of localized actions on the global climate might be, as this report suggests, quite small? Thank you for joining us on this deep dive into what is certainly a thought-provoking report. We hope it's given you some new insights and maybe a fresh lens through which to view the ongoing and very complex climate discussion.